Doctor, I am from Group 2. Today I would like to present about Assignment 2, Design and Development of Virtual Instrumentation Interface System using LabVIEW. The title is Pipeline Leakage Monitoring System using Capacitive Sensing. My name is Siti Nur Ain binti Rosli. My metric number is CE 2086. My group member is Yong Kip, DE 2026, Awina, CE 200-100X, and Faizatu Farisha is CE 200-191. The design and development of virtual instrumentation interface system using LabVIEW for pipeline leakage detection represent a significant advancement in the field of industrial monitoring and maintenance. Traditional method of leakage detection often involve a manual inspection, time-consuming, labor-intensive, and also sometimes is ineffective in identifying a small leaks. Okay, to address these challenges, virtual instrumentation leveraging modern software tool like LabVIEW offer a robust solution. And then LabVIEW is developed by National Instrument. It's a powerful graphical programming environment used for data execution, instrument control, and industrial automation.
So next, I will present our problem statement. Pipelines are critical infrastructure for the transportation of fluids such as water, oil, and gas. However, they are prone to leaks due to various factors such as corrosion, mechanical failures, environmental stress, and aging infrastructure. So these leaks can lead to significant economic losses, environmental damage, and safety hazards. So traditional methods of pipeline leak detection often rely on manual inspections, which are labor-intensive, time-consuming, and may not effectively detect small leaks or identify the precise location of a leak. Additionally, existing automated systems may lack the sensitivity or accuracy needed for early leak detection, and they may not provide real-time data or intuitive feedback for quick decision-making. So the need for an effective, efficient, and reliable system for real-time pipeline leak detection and monitoring is paramount. Such a system should integrate advanced sensor technology and data analysis tools to continuously monitor pipeline conditions, promptly detect and locate leaks, and provide operators with actionable insights. This will help in minimizing economic losses, reducing environmental impact, and enhancing the safety and reliability of pipeline operations.
The objectives are: the first one, to design and develop a monitoring system for pipeline leakage detection for oil and gas industry using LabVIEW software. The second one, to create a user-friendly interface for real-time monitoring and detection of pipeline system. The last one, to identify a significant changes in capacitance that indicate a potential leak.
So this is the scopes of this project, where it design pipeline leakage detection using LabVIEW software. Next is integrate a green LED indicator in the user interface to show pipeline leak conditions when sensor readings are above the threshold value. And last but not least is optimize the LabVIEW monitoring system for better performance and efficiency in oil pipeline applications.
I'll be explaining the flowchart for the methodology part of this simulation or project. So we shall begin with start, and then it will initialize the system where it will read the capacitance data. After that, it will simulate a signal where it will replace the actual capacitance data from the sensor in a real scenario, and then it will then filter the signal in order to reduce the noise. And next is to measure signal parameter. Then it will then compare with threshold, which means it will compare the measured amplitude with the threshold. So if the measured signal deviation exceeds the threshold, which is 5, then it will display the filter signal, the graph, and also the indicator of the leak detected will light up, which is located at the front panel at the GUI. And if it doesn't detect any crack, then it will loop back from the start. So that is all for the methodology part.
So for my part today, I will explain for the demonstration for the pipe leaking in the block diagram by using the LabVIEW. So this is my block diagram for the pipe detection, leaking pipe detection. So the first one, I'm using the simulate signal. This one will act as our capacitance value, whether it will give the normal capacitance value or abnormal. If abnormal, it will do something in this block diagram. Okay, so let's go to the next one. This one is I'm using the low pass filter. This low pass filter to filter the input signal to remove the high frequency noise. This one is to free from the noise that might cause the false detection. Okay, and for this one is gain. So this one we want to multiple the or we want to amplify the filter signal. Okay, so that it will give the best result for the detection purpose. Okay, so this one is tone measurement. This tone measurement, we want to measure the signal from the capacitance but in amplitude value. So this one I create the what we call this one so that we can see the value from the amplitude in this one. All right, and then this one I set the threshold. If the capacitance value over here, the amplitude over here is more than the threshold that we set, okay, it will blink the LED. If the LED is blink, that means it's like got the leaking in the pipe. Okay, so over here, okay, let's try to run this one. Okay, as you can see over here, the measured signal from the capacitance, the value is 1.96. Okay, this one that means is the normal capacitance value. That means the capacitor detect in the pipeline is the normal one is this one. All right, 1.96. That means it not more than the threshold, so the LED is not blink. So we try to give another value for the capacitance value. All right, let's try for the 100 frequency, let's say. Okay, 100 frequency, and then we try to run. Yes, so the LED will blink when the measured signal from the capacitance is more than the threshold that we set. All right, which is 7.07. That means it's more than our threshold. Okay, so let's go to the normal one, which is just now is this one is the normal capacitance value that we set. That means within the threshold 200. All right, so we try to run it again. Okay, as you can see over here, the LED not blinking because the measured signal from the capacitance is 1.96, which is more lower than our threshold. So that means from this block diagram we can use the capacitor sensor to detect the leakage pipeline. All right, that's all from me. Thank you. This is the last part. We want to do the conclusion for this block diagram. So the conclusion is the capacitance value is in normal value when it within the threshold. All right, if the capacitance value is more than the threshold value, which is more than 5, so that means like got leaking in the pipeline, so it will turn on the indicator. All right, that's all from me. Thank you.
So as for result and discussion, this is our block diagram that we have built in the lab view that started with the simulate signal to the low pass filter until to the leak detect. And next is the graphical user interface at the front panel. So as you can see on the first picture is that as we know that the threshold is as we know that our threshold is 5, so the first picture shows that the measured signal from capacitance is 1.96. That is why the leak detector indicator doesn't light up. As for the second image is that the measured signal from capacitance is higher than our threshold, which is 0.07, so the leak detector indicator will light up. And the graph below here displays the input signal and the filter signal.
As conclusion, the development of a simulation-based pipeline leakage monitoring system using LabVIEW presents a substantial benefits for the oil and gas industry. By simulating capacitive sensing and integrating LED indicators into an intuitive graphical user interface, which is a GUI, the system enables real-time sensor data monitoring, distinguishes effectively between normal operations and potential leaks based on predefined thresholds, and supports interactive system control and configuration. So this approach not only boosts operational efficiency but also ensures precise detection of pipeline issues, leading to enhanced safety, minimized environmental impact, and streamlined maintenance strategies. As technology progresses, these simulation systems play a critical role in advancing pipeline monitoring capabilities, and promoting sustainable infrastructure management across industrial sectors. So that's all from our group. Thank you.